Okay, let's start off with a function. Something like x squared minus 7x plus 9. And let's try to use the rule of double false position in order to find a root. Now, in order to do this, what we have to start off with is some idea where the root is, because we're going to need a guess, an x1 and an x2. So what we're looking for is we're looking for two numbers, one number which would make f negative and one number which would make f positive. So if you guys notice, if we set x1 equal to 5, what happens? We would get 25 minus 35 plus 9. So that gives me 34 minus 35, or minus 1. So that's negative. And if I let my x2 be 6, well, what happens here? I'd get 36 minus 42 plus 9. Well, that's going to be 36 minus 42. That's going to be negative 6 plus 9, which gives me 3. So it doesn't matter what these numbers are, as long as we have two different points, one where the function is negative, one where the function is positive. Now, by continuity, I know the function must have a root, because it's got to cross over the x-axis to get between any negative number and a positive number. It's a continuous function because it's a polynomial. So I'm going to use these values, x1 equals 5 and x2 equals 6, together with the rule of false position in order to approximate the root to f. Okay, well, let's proceed with the rule. Now, what the rule says is our guess, which is going to be x3, is going to be equal to x2, which is 6, times f of x1, which is 5, and that's going to be minus 5 times f of 6. And this is going to be over f of 5 minus f of 6. So calculating f of 5 and f of 6 actually wasn't a waste of time. The negative 1 is f5, because we can actually use it at this point. So I get equals 6 times f5, which is negative 1, minus 5 times 3, and this is going to be over minus 1 minus 3. So this gives me minus 6 minus 15 for 5 times 3, and then I get minus 3 minus 1, which is minus 4. So this is minus 21 over minus 4, and I get 21/4 as my approximation to the root. Now, if I wanted to, I could plug 21/4 in and see if that's negative or positive, and then I could use that to get the next approximation, and I could keep going to whatever degree of accuracy I wanted using this method.